Okay, in this next video we want to look at significant figures, why they're so important to us, how we use them, and what their meaning is. We'll have a follow-up video to this on how we count significant figures, and a third video for the next night on calculating with significant figures. Anytime we take a measurement, there's a level of uncertainty, and we are not 100% perfect or 100% exact. We have some level that we are estimating. When we think about when we take measurements, we take one value that we estimated. So there's always some level of estimation. We need to be able to communicate that level of estimation so that we can accurately tell people the level of accuracy and precision in all of our calculations. First, let's start by defining the difference between accuracy and precision. Accuracy refers to how close we are to the actual true measured value. So the value is supposed to be 20. How close are we to actually getting 20? Precision refers to the degree of agreement between several measurements. How reproducible is the measurement? I think the easiest way to show this is to show a little example. If we have a dartboard, if person A throws their darts and they scatter all over the dartboard, this would be person A over here in this left hand drawing. If they scatter all over the dartboard, we would say that they are neither accurate or precise. They don't hit the bullseye, which would be the accuracy, and they're not repeatable. They don't hit the same spot repeatedly. Second person throws their darts. This is the middle of the cases. This case here. They all hit together, but they all hit together up here in this upper corner. This is precise, but not very accurate. They all are coming together, but there's not a lot of accuracy. This third case, all of the darts hit together right around the bullseye. This person was said to be both accurate and precise. Now, significant figures are a way of keeping track of the level of precision that we have in our answers. Not necessarily the level of accuracy, but the level of precision. How much uncertainty is there in our measurements? We define significant figures as all the digits we know for sure, plus the one uncertain digit. Zeros can make this very complicated. This becomes really important when we're looking at zeros, because zeros could mean that that's a number that we want to write, but it also could be a placeholder. So it's important to remember that a zero is observed or guesstimation must be reported when we write it down. We have to have some way of keeping track of which zeros are the reported zeros. Let's look at these pairs of readings. We have X over here on the left, Y over here on the right. X is between 0.2 and 0.25. We might say this is 0.23 or 0.24, the 3 or 4 being our estimated digit. Y is directly on 0.4. We know it is definitely 0.4, and we're going to estimate a 0. Rather than 0.39 or 0.41, we're going to say it's exactly 0.40. So this 0 is very significant to us, and is an important digit for showing our level of precision. Second scale. Here we have a scale of tenths, or thousandths. So in the first case, the X on the left-hand side, we might indicate that as 0.23 and then an estimated digit of 6 or 5 or 7. Once again, with the Y over here on the right-hand side, based on the scale we're dealing with, we know it's not 0.33, it's not 0.41, it's right at 0.40, and we're going to say 0.400, with both of those zeros being very important and significant figures. Every measurement will contain at least one uncertain digit, and only one uncertain digit. The number of significant figures that we have in any calculation is the number of certain digits plus one uncertain digit. In the next video, we're going to look at how we count significant figures when we see a written number. But the key to significant figures is making sure that you are writing all the digits you know plus one that you estimate, and including any zeros that are estimated or known digits.